Number 7, identify which equations represent redox reactions, providing a name for the reaction if appropriate. For those reactions identified as redox, name the oxidizing agent and reducing agent. Show oxidation numbers for the relevant elements. I'm going to be showing oxidation numbers throughout the whole thing just because it's easier for me to see and it's one of the best things to kind of, go over. I know that our zinc carbonate is going to have a total of a 0 charge. However, I know that carbonate has a -2 charge overall. I know that carbon has a +4 charge, and I know that oxygen has a -2 charge. Now, how this equals, -2 charge overall is because there's 3 oxygens, which makes that 8. Wait, no, that makes it 6. Oh my gosh, my brain. 6 plus 4 equals -2. That's why we have that -2 charge overall. I also know that we technically want this whole compound to equal 0. I'm going to get rid of that -2 over the carbonate. And so that means our zinc has to be +2. That means over here it's going to be +2. Our oxygen is going to be -2, which makes a 0 charge. And we know that our CO2, we have +4, -2. That's going to be a 0 charge. So overall, we have a bunch of 0 charges, which makes this a non-redox reaction. It's all going to balance out to 0. And that's why it's a non-redox reaction. That doesn't mean that everything that we have here is going to be zeros. In fact, this case is kind of funny. Our gallium bromide, because these are in natural states of liquid, these are going to have a 0 charge. However, our ending is going to be 2 galliums per 3 or 6 bromines. This is where you kind of want to figure out, we want this to be 0 overall. We know that bromine is going to be -1. And so in order to figure out our metal, we're going to see that this is going to be 6, a -6. And we know that gallium will have to be a +3 in order to multiply by that 2 to get a +6, which cancels that out. In this case, we're going from 0 to +3, which I'm going to write down. Gallium is going from 0 to +3, and bromine is going from 0 to -1. Because gallium is losing electrons and instead is turning positive, we would say that gallium is being oxidized. Sorry. And we know that bromine, because it's going and gaining electrons, it's going to be reduced. Now, it's going to be a little funky because usually, and I'm just going to move this up a little bit, make it a little smaller. It's funky because usually what's oxidized means it's the reducing agent. And what is reduced is usually the oxidizing. However, I am going to show you something that I have used, forever, and that's Leo, the lion, goes grr. Basically, that's lose an electron equals oxidation And gain an electron equals reduction. I know it's kind of funky to think about, oh, if I gain something, that means I'm being reduced, but you have to remember that electrons are negative. So if you have a 6 and you're adding a -3, you're technically going from this big old 6 to a 3, and you have reduced yourself. I also like to think about it as, soup. If you've ever had soup, if you've ever had stew, you put a whole bunch of stuff in the pot, you wait a little bit of time, and after that little bit of time, there's less liquid, but there's more good stew. But that's how I like to, think about reduction and stuff like that. Anyway, on to our next question. We know that hydrogen is usually a +1. And we know that in this case, oxygen is going to be -1. And because of that, we know that in this case, it's +1. However, because there's only a single oxygen, that's going to be -2. And our, natural oxygen isn't going to have a charge. So in this situation, we are having a disproportionate reaction. And all that means is oxygen is both the oxidizing and reducing agent. How it's both oxidizing and being the reducing agent is just because O is going from a -1 charge to a -2 charge, which means it's gaining an electron. That's not right. Something's wrong here. Oh, I'm sorry. I'm looking at the wrong O. This O2 right here, it's going from -1 to 0 because it's O2 and not O. This is technically like a little 1. It's just oxygen. This O2 is actually going from -1 to 0, which means it is losing an electron, which means it's being oxidized, but it's also the reducing agent. Anyway, sorry for the confusion, guys. That was my bad. We know that chlorine has a -1 charge, which means that this barium has to have a +2 charge. We know that SO4, our sulfate, has a -2 charge, which means our potassium has to have a sulfate has a -2, which means our potassium has to have a +1 charge. Because we know that this is +2, -2, this is a big ol' 0. And we know our potassium is a +1, -1, which makes this a big ol' 0. So in this case, this is a, what is it called? Ooh, it's on the tip of my tongue. It is a precipitation reaction. It's a precipitation reaction. I could not remember precipitate for some reason, but it's not a redox. Now, why is it not a redox? Is because, you know, it's going from +1 to +1. There's no change here. This is -1, this is -1, this is +2, this is +2, this is -2, this is -2. They're all the same. So it's not a redox reaction. It's just a precipitation reaction. I'm not going to write it all out. I'm just going to write it as Deborah put it. It's a PPT. Lastly, RE. We know that hydrogen is a +1. So in this case, our carbon right here is a -2 to have a 0. We also know that oxygen by itself is 0. Now our CO2, our carbon is a +4, while our oxygen is a -2. This leaves us with a -2 charge. Oh, no, it doesn't, because that's 2. And then our hydrogen gets a +1, and our oxygen is -2. Now, I know that's kind of confusing because over here in this earlier equation, we said that the O2 on this side, I'm going to do it in another different color, only relates to the O2 on this side. This O2 does not relate. In this situation, it's kind of similar in one, that the sense that this O2 is going to relate to this O2, not to this one, even though it has the same charge as this other one. So I don't want you to get confused on that one. In this case, we can obviously see that carbon is going from -2 to +4, and oxygen, or our O2, is going from 0 to -2. In this sense, we would say that carbon, like our little saying up here, it has lost electrons. So our carbon is oxidized. But it's also the reducing agent. While our oxygen is reduced. But it's also the oxidizing agent. And so that's it for number 7. I hope